We will be learning algebraic expressions today, but to begin, we'll start with a numerical expression. A numerical expression is made up of numbers and operations. So pause the video and see if you can write some numbers and operations before we go over it. 5 plus 8 is a numerical expression, has 5, 8, and addition in it. 7 minus 3 times 2, using subtraction and multiplication. And the algebraic way of writing division right here, this is read 18 divided by 9. Algebra introduces using a letter in place of a number when you don't know what the number is. Let's say we wanted to add 6 to a number, but we don't know what the number is, or we want to let you choose any number. Then we would leave a blank or an empty box for the number and say plus 6. It becomes algebra when we put a letter in that box. Instead of leaving it a box, I can call it A, B, C, or X, Y, Z. So instead of writing box plus 6, I might write X plus 6. This just became an algebraic expression because it uses letters for numbers. So if I wanted to say take a number and divide it by 5, instead of leaving a box there, I might call it n divided by 5. And n can be any number that you choose. If we say John is 11 years old, then in 1 year, John would be 11 plus 1 year old. Or 2 years ago, he would have been 11 minus 2 years old, or 9 years old. Let's say that we don't know how old Jane is. If we don't know how old she is, we'll just assign her a letter. Let's call her J since her name starts with J. Well, in 1 year, she will be however old she is now, J plus 1. 2 years ago, she would have been J minus 2 years, J being her age now. 3 years from now, she'll be J plus 3. We simply replace her age with a J because we don't know her age, but we know 1 year from now would be plus 1, 2 years ago is minus 2, 3 years from now would be plus 3. Pause the video and see if you can write algebraic expressions for these 5 statements. To add 5 to Z, we'd start with Z and then add 5. Because you get the same answer when you add, I could have also written 5 plus Z, and these both would have been identical, but this is actually the way it's worded. In the second one, adding Z to 8, I start with 8 and add Z. Again, because you'd get the same answer if you took Z plus 8, this would also be acceptable. Subtracting X from 10 means I start with 10 and subtract X, whatever X is. This one cannot be written the other way because 10 minus X is not the same as X minus 10. You would get a possibly negative number if X was bigger than 10. So subtraction is not commutative, meaning you can't do it backwards like you can addition. If you can do it backwards, it's called commutative, and you can do it if you get the same answer. On the next one, we start with D, and I want 4 more than that, so I'd add 4. Again, because addition is commutative, meaning I can write Z plus 5 or 5 plus Z. In this case, I could also write 4 plus D, and they would both give me the same answer. And the last one, finding 7 less than K, I'm starting with K, and I'm taking 7 away. And that's the only way that one can be written. 7 minus K gives me a different answer, so it's not possible. Subtraction is not commutative. For example, find the value of x plus 6 when x is 8. That means we're going to take the x and replace it with 8, add 6, and find the value. 8 plus 6 is 14. So when x is 8, the value is 14. When x equals 5, we would take 5 plus 6, and the value would be 11. Find the value of each of these algebraic expressions when the value of x is equal to 15. Pause the video. On the first one, we would take 12, replace x with 15, and get an evaluated expression of 27. On the second one, we'd replace the x with 15, add 5, and the evaluated answer is 20. On the next one, we have 30 minus 15, so that one's value is 15. And on the last one, we would take 15 minus 10, and that one evaluated would give us a value of 5. Now we will move into multiplication. Let's say a box has 10 apples. Well, what if you had 2 of those boxes? You would have 10 times 2 apples, or 20 apples. We could also say you have 2 times 10 boxes of apples, which is still 20 apples. If we don't know how many apples are in the box, then we could say that there are A apples. So if I had 2 such boxes of those, then I would have A times 2 boxes, or 2 times A boxes, or A groups of 2, 2 groups of A, or the algebraic way to start writing multiplication is simply 2A, because this X kind of looks like the multiplication symbol, and we won't know if it's an X or a multiplication symbol. So we simply say 2A, and we know that that means actually 2 times A. What are some other ways to write 4K? Pause the video and see how many you can come up with. You could have 4 times K, K times 4, K groups of 4, 4 groups of K. How about K times 9? Just pause the video and see how many other ways you can write that. You could have 9 times K, 9K, K groups of 9, and 9 groups of K. Evaluate these algebraic expressions when n has a value of 2. Pause the video while you write them down. In the first one, remember 12n means 12 times n. In this case, replace the n with 2, so 12 times 2 is 24. In the second one, we replace the n with 2 again, so 6 times 2 is 12. In this one, we replace the n with 2, take it times 5, and we get 10. And in the last one, again, 8n means 8 times n, or 8 times 2, which is 16. So this would be evaluating the multiplication expressions when n had a value of 2.